It's kind of hard to grasp, so I will be explaining how it goes. The way we're going to do this is by looking at the EMF. Okay, so here we have an EMF of E. An EMF of E. And let's take the resistance as R, and a current flows through of I. So what we're following over here is basically V equal to IR. Instead of E, we can just write here V, so it's easier for us when we're doing the calculations. And the power is equal to IV. As in, if we have this voltage and this current, we're gonna get this power, which is the original power, OG power, right? So what happens when the student connects the lamp and the cells as shown? Now we need to think this in a very methodical way, because there is two EMFs, and what I'm gonna do is I'm gonna draw another diagram right here, but I'll just shift all the elements a little bit. We got our EMF here and EMF here. What I did here is that I just basically took this and shifted it to this side, and I took this and shifted it here. And then what I'm gonna do next is I'm gonna take the lamps. I'm gonna keep this one here itself. I'm gonna keep this one here and this one here. Okay. Now, this cell gives out a voltage of V, and this one gives out a voltage of V. Now I want you to imagine that the voltage is going through here and here, from here to here, right? And as it goes through this, this is 1 and this is 1, okay? It's kind of like a series circuit. I want you to imagine this as one of the component, and this together is another component. As in, you have just a series circuit with the EMF and everything, and this over here is this one, and this is another bigger component, which is like a combination of this over here. Okay, so we're gonna use R and R, and you guys know how to calculate the resistance in a parallel circuit. So R into R by R plus R. This is what I'm doing for here, right? So that is 1 by 2 R, and here it's just R. So how is V going to divide between these two? The way that it's going to divide is, first you will have to take the total R. So R plus 1 by 2 R. 1 by 2 R is going to give you 3 by 2 R. And then once you have the total R, you're going to use the potential divider method, which is R divided by 3 by 2, or I'll just write it as 1.5 R times V, which is 1 divided by 1.5, 2 by 3 of V. Okay, so essentially this lamp over here is getting 2 by 3V, 2 by 3V, sorry about that. And this over here is just it's just gonna be V minus 2 by 3V, which is 1 minus 2 by 3. It's gonna be 1 by 3V. essentially this one and this one, both of these resistors are going to get 1 by 3V because they are in parallel. So it does not matter, they both are going to get 1 by 3V. Okay, now we can just remove these stuff, and now we're going to look at the same thing but with the other EMF. Okay, so this is your another EMF, and now I want you to imagine that this over here is one component, this together over here is another component. The same thing applies. Here the resistance is R, and here the resistance is R times R divided by R plus R, which is again 3 by 2R. Oh, I'm so sorry. Which is 1 by 2R. Okay? And the same rule applies. The total R is 1 by 2R plus R 3 by 2R. Okay? That means that the voltage that goes across this one over here is gonna be 2 by 3R, 2 by 3V, and that goes over here is 1 by 3V and 1 by 3V. Okay, now we got our two voltage values for each of the lamps. These are for this lamp, these are for these lamp, and these are for these lamp. Okay, now we're gonna do some addition. Okay, so first is for L1, this is L2, and this is L3. Now I want you to imagine for L1 the total EMF or the potential difference across that is 2 by 3V plus 1 by 3V, which is just V. And the same goes over here. This is also V, but over here it is 1 by 3V plus 1 by 3V is 2 by 3V. So it does not get the full voltage. What V needed was V and I. Well, all of them gets I because they all have a resistance of R. However, not all of them gets the V. So it is only lamp 1 that gets the full V and the full I, and it is lamp 3 which gets the full V and full R. But lamp 2 does not get the full V, it only gets 2 by 3 of V. That is why our answer is going to be C. Only lamp 1 and 3 light with normal brightness, which was the power over here. Okay.